Welcome. This is the 7th video in our series on statistics, and in this video we're just going to go over the distinction between an observational study and an experiment. So in an observational study, all you're doing is collecting data. You're not messing with the subjects themselves, so you're not imposing a treatment. This is in direct opposition to an experiment where you still collect data, but you are directly manipulating some variable. You are adjusting the participants in your study. Some of them are getting a treatment, and some of them are getting some other kind of treatment. So some variable you're controlling. So here are some examples of observational studies. We have any type of survey. So anytime you're just asking people questions, you're not really trying to mess with them or change a variable. Although poorly worded questions maybe can be viewed as imposing your treatment, but generally a survey is an observational study. If you sit down and count how many birds are in your yard in an hour, you're not doing anything to the birds, you're just having an observational study. And if you just take temperature of somebody or everybody in the room, that's just an observational study, you're not necessarily doing anything. So you might take some time to think up some observational studies yourself, but one that we could write, is keeping track of hours of direct sunlight for a plant. This would be opposed to an experiment where you have two plants. Indoor, and one gets 8 hours of light, while the other gets 12. Thus you having direct control over a single variable. You're very much applying different individuals in your sample different treatments. So the other pieces in this list these are experiments. So our first example was the smallpox study, where some people were getting the inoculation and some people weren't. And then the other items in this list correspond to entries in the list about observational studies. So if you count how many birds are in your yard on one day without a bird feeder, but on the other day with a bird feeder, you controlled some variable. The different days have different treatments. If you take the temperature of everybody in the room, but first you have half the people do 100 jumping jacks, you're assigning a treatment to the different individuals in the study. Alright, so those are kind of examples to piece out the difference between observational study and experiment. We have this one other item here to get at the heart of the distinction between correlation and causation. And the purpose of an experiment is to determine a causal relationship between two variables. So the words correlation and causation, they always refer to a relationship between two variables. You don't say one variable is correlated. You say two variables are correlated to each other, or one variable is causing another variable to adjust in some fashion. And correlation just means that the values vary together. So here we have on the vertical the divorce rate in Maine on the left, and margarine consumed over on the right. And you can see as time progresses, especially for these first 6 years, the consumption of margarine goes down, and also the divorce rate goes down. There's this lull and a pickup between 2005 and 2006, and then things flatten out again. So these two variables are definitely correlated. And that is not a joke. That is the correct use of the word correlation. They are varying together. What they are not doing is causing one of another. There is no causal relationship. So this example is clearly a joke in terms of it's not showing a causal relationship, but I'm trying to use it illustratively because people often use the word correlation when they want to say causation, and they often believe there's a causation when there's really just a correlation. It is totally fine to say these two variables are correlated. They are. But there is nothing, no evidence to make you believe in a causal relationship. So in the next videos, we'll talk a bit more about how to design a good experiment so that we can make causal statements. See you there.